BSc Learning course on the Greenlock Logistics as a Service Marketplace, a web application built and tailored to promote greener and more sustainable urban last mile logistics. My name is Amalia Bozinaki. I'm a project manager officer at Frontier Innovations, and I have spent the past 13 years working on digital transformation in the logistics sector. I led the team that designed, built, and piloted this platform, which means I can take you through it from the inside. Over the next 10 minutes, we will cover why it was built, how it is architected, the technical intelligence it embeds, and what the real world pilot results tell us about its impact. Before we dive in, here is how the session is structured. We start with a problem, the urban logistics reality that makes a platform like this necessary. We then look at what the LAS actually is, who uses it, and how it was built. We cover the two intelligence engines that sit at its heart, dynamic pricing and nudging mechanisms, and we close with the results from the pilots in Flanders. Each section is designed so that both a policy or business audience and a more technical audience can follow. We will signal clearly when we go deeper into the technical side. Urban logistics is under pressure from multiple directions, and the challenges reinforce each other. On the operational side, a fragmented market with no unified coordination, limited visibility across providers, inefficient small volume deliveries and pickups, and greener options that are hard to find and compare. On the policy side, the EU has committed to zero-emission urban logistics by 2030, but commercial markets do not yet have the tools to get there. The external cost of urban freight, congestion, emissions, noise remain largely unpriced, and the sheer complexity of the sector has historically resisted any single coordinated solution. These are not separate problems, they are the same problem seen from different angles, and the last marketplace was built to address them together. So, what exactly is the LAS? At its core is a web application that connects two sides of the market: demand, local shop owners, a consumer who needs things picked up or delivered, and supply, logistics service providers who carry those deliveries. But it does more than connect them. It embeds city policies directly into the platform logic. Access windows, low emission zones, off peak hours, these are not external constraints applied after the fact, but built into how quote options are generated, ranked, priced, and incentivized from the start. The platform operates on three levels simultaneously. At the transactional level, it gives users a single interface to search, compare, and book deliveries across multiple providers instead of dealing with each one separately. At the coordination level, it standardizes parcel attributes, consolidation opportunities, and service levels agreements across providers who would otherwise be operating incompatibly. And at the policy level, it translates municipal sustainability rules into price signals and credits so that the most sustainable options is also the most visible one during the request. The platform's response to the challenges we just saw is therefore fourfold: better coordination across the supply chain, more efficient logistics through consolidation, greener choices made accessible and attractive, and improved transparency for all parties. Before we look into the core logic of LAS, let's take a moment to see how it was tailored to meet user needs. The detailed interaction of each user type will be covered in a separate lecture. Here, I just want to give you a sense of who uses the platform. LAS was built around three user types, each with a distinct role. Starting, local shop owners are the primary demand side. They request pickups by adding parcel details, compare quotes, and place orders. Consumer declare the delivery preferences such as time slotted delivery location, and the platform generates options that match their needs. On the supply side are the LSPs who they receive assigned orders, manage the fleets, and create track and trace events of the orders in real time to be seen by the demand side. One platform with three roles, each seeing exactly what they need and nothing they don't. Now it is time to dive into how LAS was built. Fair warning, this is the most technical slide in the course, but stay with me because understanding how the platform is built is what makes everything else cling into place. What you see on the screen is the reference architecture of the LAS organized in layers, each with specific reference to the technology stack that powers it. If you are not from a technical background, here is the one thing to take from this slide. Every layer exists for a reason. The front end is what the users see, the back end what makes decisions, and the database is what remembers. The external engines are what makes the platform intelligent. Each layer has a job and they only work because they work together. The platform is built as a standalone web application following a microservices architecture. Each functional part runs as a separate independent service. The practical benefit is resilience and flexibility. If the database, for example, needs to be upgraded, you do it in one place without risking the rest of the system. To keep every service portable and consistent across environment, each one runs in its own Docker container. Think of it as a self-sufficient package that behaves identically whether it is running on a developer's laptop or a live server. Afterwards, the Docker Compose manages how all the container stats communicate with each other and terminate. On the technology side, the front end is built in React, the backend in Java 17 with Spring Boot, and all data are stored in a PostgreSQL database. Nginx acts as the external gateway handling security, meaning terminates the SSL and enforces HTTPS, and the routing, which directs incoming traffic to the right internal service. All service-to-service communication are protected with the JSON Web Tokens. All technology stack chose deliberately in order the last can be involved, maintained, and be reused in other contexts without being tied to every other component built within the Greenlock project. Two services on the right side of the diagram, the dynamic pricing developed by Mobi and nudging engine by Factual, are external, meaning that from the marketplace perspective, they are black boxes. We know what we send them and what we get as a response, but not how they develop internally. What matters is the contract. The marketplace backend calls them at the right moment with the right inputs and uses their outputs to build the quote that the user sees. Finally, the data space connection, built using FIWare connectors, works asynchronously in the background. Once an order is placed, the data are published to the Greenlock dataspace and picked up by the Bring Your Device application to proceed with the physical delivery. The dynamic pricing is one of the two intelligence engines built into the platform. Its job is to generate pickup or delivery prices for upcoming days and slots in a way that steers users away from immediate, costly, high-emission options towards more sustainable ones. Every price is calculated from a 5-component formula. The total cost is the sum of the base cost, the distance, the size, the consolidation, and the refrigeration surcharges where applicable. The base cost reflects urgency, for example, ASAP next day time categories carrying different multipliers. Distance is based on polygon-defined operational zones rather than a flat per kilometer rate. Size accounts both weight and volume across small, medium, and large parcel categories. The most powerful component is consolidation. When multiple confirmed orders fall within the same time slot, the platform progressively reduces the unit price. For example, in the Mechelen pilot, on Mondays and Fridays, the first 4 confirmed orders in a slot received a 14% discount, while from the 7th confirmed order onwards, the discount reached 27%. The result was measurable. Users actively shifted the behavior towards the slots with the highest discount, which were also the slots best suited to efficient consolidated delivery. The nudging engine is the mechanism that converts city sustainability policies into visible, tangible incentives at the moment the user is choosing a delivery option. The flow is straightforward. A city authority defines a policy rule, for example, awarding a credit when a delivery is made by cargo bike within a defined delivery zone. The rule is stored in the nudging engine. When a user runs a quote through the LAS, the bucket invokes the nudging engine. The engine evaluates every option against the stored rules, and if a match is found, a granted credit is attached to that option in the quote results. The user sees the incentives directly at the point of decision. Critically, this mechanism preserves freedom of choice. Credit rewards sustainable behavior; they never restrict alternatives. Through the pilot deployment, three production refinements were made. First, traceability. Every granted subsidy now includes a field identifying the exact policy rule that triggers it, enabling auditability for city authorities. Second, advanced logical operators give specifically the ability to include or exclude trip attributes such as zones combined with vehicle type, enabling much more granular policy targeting. Third, bulk rule creation, which allows an entire policy framework to be deployed in a single API request rather than rule by rule. Now, let's look at some of the results because LAS was not just built in theory, it was tested under real operational conditions across 3 living labs in Flanders in 2 iteration cycles. Each pilot targeted a different use case, and together they validated the platform involving external to the project stakeholders. Let's look at which one told us, starting with Ghent. The numbers you see on the slides tell part of the story, but look at the findings underneath. 93% of orders came from the food and drink sector, which tell us something important about who last mile consolidation actually served. Another important outcome was that one provider reached an 85.7% consolidation rate simply by combining Greenlog orders with existing operations without changing anything, but simply coordinating better. Shop owners were highly satisfied, and their main proposition for upscaling glass was recurring orders and real-time tracking. Moving on in Mechelen, which was the largest pilot in volume, meaning 531 orders from 64 active users. Let's focus, however, on the behavioral impact. A 55% reduction in delivery trips, prices went down 29%, and crucially, the dynamicity in price shifted orders placement towards Monday and Friday, which also was the most consolidation-friendly slots. Users did not just use the platform, they adapted to it. Finally, Leuven, which is the most different of three, and the findings reflect that. Behind the order numbers is 1.4 tons of food saved from waste. The bullet points here are less about efficiency and more about what it takes to make this kind of logistics work in practice. Simple onboarding, fast participation, a city authority willing to act as the connector between the commercial and social world. Stand out from everything we have covered. The platform validates the model. A single architecture can serve fundamentally different urban logistic use cases. That is a demonstrated result, not a designed assumption. Second, pricing and nudging drive real behavioral change. Consolidation reduced delivery trips by up to 55% and cut costs by 29%. The nudging shifted demand to more sustainable choices without enforcing anything. And the platform is ready for what comes next. Production maturity confirmed and learnings already being transferred to follower cities Arad in Romania and Helsingborg in Sweden. Thank you for completing this course on the Greenlock Glass Marketplace. If you have questions about the platform, the pilots, you are very welcome to reach out to me directly. As you can see, my contact details are on the screen. This course is part of the broader e-learning series powered by Polis. The companion course covering the digital photo tower and work through the last platform is available separately.